All right, let's do a quick review before we get started on the similarities test review. What are the 3 ways that we can prove triangles are similar? We're going to match them with the descriptions in each box. So the first description says if 2 corresponding angles are congruent, then the angles are similar. If I have 2 corresponding angles that are congruent, that is what we call angle-angle similarity. And for example, you might have 2 triangles where we know that they have 1 pair of corresponding angles and a second pair, where those corresponding angles are congruent, and therefore we could say that the triangles are similar. The second one says if all corresponding sides are proportional, then the triangles are similar. For this example here, this is called side, side, side similarity. And this is where you can put up a proportion for all sides. And so this one's, it's kind of hard to draw a picture of necessarily, but just remember that you're matching up corresponding sides in the 2 triangles. So let's say those sides are corresponding, these sides are corresponding, and these sides are corresponding. Those are the ones that you would want to be proportional. And you'd have to show that all 3 proportions are exactly the same. In the last one, it says 2 corresponding sides are proportional and the included angles are congruent. Then the triangles are similar. And this is what we call side, angle, side similarity. And so for the picture for this one, it's important that you remember which angle we need when looking at the side. So if I have like, let me just highlight instead of draw. If I know that this side and this side, they're corresponding, and I know that this side's corresponding to this one, and I can see that the proportions are the same, the last thing I need to know is this angle. This angle here is congruent to this angle. And the reason I need that one and not the other 2, because I need the angle where the 2 sides that we're looking at meet. So where the pink and green side meet, I need the angles there to be congruent in order to be considered side, angle, side. Looking here, it says which of the following are similar, and we want to write the similarity statement and state the reason. So just looking at them at first glance, this first triangle here, RST, I see that angle R is 83 and angle T is 55. I don't see any other triangle that has 83 and 55, but it might be helpful to find the missing angle in this triangle. So if I'm looking for angle S here, I can find it by using the triangle sum theorem, which says that all 3 angles sum to 180. So I'm going to do 180 minus 83 and minus 55, the 2 angles that we know. And when I subtract the 2 we know away, I'm left with 42. And so 42 has to be the missing angle. Now that I see 42, I actually can relate this to one of the other triangles because I've got angle 42 degrees right here, and this triangle over here has an angle of 42, and we have that common angle of 55 as well. So in these 2 triangles, they have 2 angle pairs that are congruent. And so I know that those 2 have to be similar triangles. So I'm going to do pair number 1, triangle RST is similar to triangle W, because R and W are the 2 that we did not pair up, but they would, so they go together. S would go with U because they're both 42, and T and A because they're both 55. And the reason is angle-angle similarity. Now, if you had done the triangle sum theorem for triangle WUA, you would have found that W was 83 degrees. So we really know that all 3 angles are the same. In this next triangle DBC, I notice that what I have is starting to look like side, angle, side, because I've got a side here, the angle, and then the side here. In order for side, angle, side to be true, I need another triangle that also has an angle of 29 degrees. And as I'm looking, I notice that we've got the 29 degrees here and 29 degrees here. So it's possible that these two are similar. What we need to test now is if their sides are proportional. So I'm going to set up my proportion. I'm going to start with this side here, BD, and side KL, matching those two up. And if you're confused about this, remember, if I'm going to test to see if they're proportional, I'm going to match up the smaller sides and the bigger sides. Even though it doesn't have a similarity statement, the only hope I have of them being proportional is if the smaller ones go together. So I'm going to set this up. I'm going to do BD over KL, which is 6.5 over 13. And 6.5 divided by 13 is 0.5. And now I'm going to do the same thing for the other pair. So BC and KM. I'm going to do BC over KM. Notice I am starting again with the triangle to the left. Remember, you have to be consistent. BC is 9, KM is 18, and 9 divided by 18 again is 0.5. So since these two are the same, I know that these are side, angle, side, similar triangles. So I'm going to start with the similarity statement. Triangle DBC is similar to triangle LKM, and the reason is side, angle, side similarity. Now, the last two that we could match up here, I have side lengths for all three sides. So we're going to test to see if it is a side, side, side proportional, a side, side, side similarity. So I'm going to match up the sides. I'm going to start with the longest side. So 20 has to go with the side that is 15. 12, which is the smallest, has to go with the side 9. And 14 would have to go with 10. And I'm going to test them. So I'm going to start with the purple side. So 20 over 15. I always just go left to right. You don't have to, but it's good because then I have a habit that I can just do every time. So I get 1.33. Next, I'll do the yellow side. So 14 over 10. So 14 divided by 10 is 1.4. Those are already not the same. So I don't even have to test 12 over 9 because right away I see that these two are not the same, so they are not similar. So we only have two similar triangle pairs here. In this next one, number 2, it says, in the figure, we know that BC is parallel to DE is parallel to FG, and we want to complete each proportion. So remember, the parallel lines in triangles like this set up proportional sides. And so we can use that to set up these proportions. And it might be good to highlight here. So I'm going to start with the first one, A. It says AB, which is right here, over BD, which is right here, equals AC, this side, over what? Well, to match what is happening on the left side, I know that I'm going to want this piece right here. So it should be over CE. All right, I'm going to erase some. I might keep going back to the picture here. So the next one, I've got AE over EG. And I'm going to start with the one we see fully first. So AE is right here, over EG is the smaller piece, equals what over DF? Well, to match what I have on the right side, I know I would want this piece right here, which is AD. All right. right, the next one is DF over blank equals EG over CE. So we're just doing those smaller pieces here. So I want just this smaller piece right here to complete the picture. I'm going to do BD. All right. The next one says AF over AB. So AF, the longest, over AB, that small piece, equals blank over AC. Well, I know I want to put the long piece over the small piece, so here's the long piece here from A to G. That's how that one would fill in there. All right. Next one here, we've got BD over CE. So BD is right here over CE. Okay, so now notice we're matching up across the triangle. That's okay. We just need to make sure we do that on the other one. So BD over CE equals blank over EG. What would match this pattern? That would be this side here, DF. And that last one, we've got AB over AC. So AB over AC equals BF over what? How could I complete this pattern? I would want C to G. So CG here. All right, on the next part, it says solve for the indicated values. We know, and it's just like these ones before, right? We know that these lines are going to break them up into proportional pieces. So I can set up proportions based on the image. I'm going to set up my proportion of SP over QS equal to what I'm looking for, PT over TR. That's how I'm going to choose to do it. Now, as we saw before, there's lots of different proportions that you could set up. I just like to do the bigger over the smaller. That's just what we went with for this one, and I can change it up for the next ones too. But as long as your proportions match, just like we saw before, you should be okay. I'm going to plug in the numbers now. So PS is 28. SQ is 12. Equals, PT is our unknown, and we can even label it X, just so we know that's what we're solving for, and TR is 7. Now we've got our proportion set up. To solve this, we're going to cross multiply. So I'll start here. 12 times X is just 12X. And then 7 times 28, we get 196, and I set those two sides equal. Now I need to solve for X, and I have 12 times X. So to get rid of that 12, I would divide. I'm going to divide both sides by 12 because those two will cancel. And I'm left with X equals, I got 16.33. And so there's our answer here. PT is 16.33. All right, for the next one, the first thing I'm trying to find is CE, which is this piece right here. Again, I'm going to set up a proportion. So I'm going to go with AE over CE equals, so AE is here. I could match that up with AD. AD over, to match up with CE, I would choose BD. Plugging in what I know, AE we know is 6. CE is what we're looking for. AD is 15, and BD is 18. All right, I'm ready to cross multiply. So I'm going to start with 6 times 18, and it doesn't matter which order you go in, left to right, right to left. All right, I could have done 15 times X first. And then X times 15 is 15X, either direction. All right, now to continue solving for x, I need to get rid of that 15. So I will divide both sides by 15, and I get 7.2 equals x. Remember, I'm just using my calculator for these. So if you can't do it in your head, neither am I. Use your calculator. So that is the distance for CE, 7.2. But now this follow-up question asks for CA. CA is the total distance of this side. Well, to find the total, if I know each piece, this one's 7.2 and this one is 6, I'm just going to add them. 7.2 plus 6 is 13.2, and so that's what CA is. All right, for 5, I'm going to start by looking for xy. Well, xy is right here, and I don't actually have to set up a proportion to solve it. I know the total distance is 30. I know this piece here is 18. So here's the total distance is 30. This piece is 18. So if I want to find this missing piece, I can take the total distance, subtract the piece I don't want, and it'll leave me with the piece that I do. So we're going to do 30 minus 18. And you should get 12. So that smaller distance is 12 right here. And now I can use that to find xz. So on the other side, here's xz. I'm ready to set up a proportion. I'm going to do xy over yu equals xz over zv. Plugging in what I know, xy is 12, yu is 18. xz is what we're solving for, and zv is 30. I'm going to cross multiply, so 12 times 30 first is 360 equals 18 times x is 18x. Now I'm going to divide both sides by 18. And I get 20 equals x. So that's 20. All right, in example 6 here, I have that these two triangles are similar. I want to find GR and SG. So GR is this piece right here. I don't know this piece, so I cannot find GS. So really, I don't know these two pieces. I know HR is 30, and then I know that the total distances are 66 here and 110 here. So instead of being able to, like, I don't want to subtract and find this missing piece. That's not going to help me. And I can't find this piece without setting up a proportion. So our proportion here has to be a little bit different. Instead, what we're going to set up is a proportion of the pieces that we want to the whole sides that they are a part of. So I'm going to set up HR over RT, the whole side, equals RG over RS. Now I can set up a proportion. It still works the same from here. HR is 30, RT is 66, RG is what we're looking for, and SR is 110. All right, now I'm going to go ahead and cross multiply here. 66 times x is 66x. And then on the other side, 110 times 30 is 3,300. Next, I'm going to divide both sides by 66. These cancel. And I get x equals 50. So we just found GR is 50. Now, how can we use GR being 50 to find SG? Well, we know that then if this piece is 50, the whole distance is 110, I can find the missing piece by subtracting. So I'm just going to do 110 minus 50, and I get 60. So SG must be 60. All right, here we go. We want to do some more solving problems. And in these ones, we are using the fact that the triangles are similar, Because they're similar, again, we can set up like proportions. And I'm given a similarity statement that's going to help me match up corresponding sides. So here, JK, this side here, corresponds with JQ, this side here, based on, because they're both the first two letters in the triangle similarity statement. The next one would be JL, because that's what I have information about. Notice I did skip over KL, but because it's not labeled. So next one I have is KL, or JL, so J to L, first to last, and then that would correspond with JR. So now I can set up a proportion using these corresponding sides. And so I'm going to do RJ over JL should equal QJ over JK. Oops. And I'm just going to plug in what I know. So I know that RJ is the expression for x plus 7. JL is 99. Equals JQ, which is 55, over JK, which is 99. And I'm going to go ahead and cross multiply here. I get 99 times 4x plus 7 equals 99 times 55 is 5,445. Next thing I'm going to do is divide by 99. Notice I'm not going to distribute. I want to just divide by it. Get rid of it, deal with some smaller numbers. So when I divide both sides by 99, I'm left with 4x plus 7 equals 55. And so now I can start solving from there. So I'm going to start by, now this example, you might need to draw down your line. And remember, we're doing opposites. I'm going to subtract 7 from both sides. So I get 4x equals 48. Divide both sides by 4, and x equals 12. So x equals 12. Now we want to find RJ. RJ is represented by this expression right here, and now we know x. So we can find it by just plugging in 12 for x. 4 times 12 plus 7. 4 times 12 is 48, plus 7 is 55. And the last thing we're asked to find is RL. Well, RL is this total distance right here. And remember, to find a total, we just add. And so if RJ is 55 and JL is 99, I'm going to do 55 plus 99. And I get 154. That is the total distance there. All right. In question 8, rather than having a similarity statement, we have, again, one of those proportional triangles with parallel lines. And so I can actually use that to set up my proportion. I'm going to go AH over HC equals AG over GB. And I'm just doing those small pieces over the leftover pieces. All right, I'm going to plug in what I know here. So AH is 2x minus 1. HC is 21. AG is 4. And GB is 12. And we're going to go ahead and cross multiply. So starting here, 21 times 4 is 84. Equals, I'm just going to do 12 times 2x minus 1 for this other side, because it's easier to just divide away the 12 from the start rather than distribute. So I'm going to divide both sides by 12 here. And I get 7 equals 2x minus 1. And now we're into solving. And so I'm going to go ahead and start by, for this problem, adding 1 to both sides because I need it to cancel out. So 8 equals 2x. And then the next thing I want to do is divide both sides by 2, and I get 4 equals x. So x is 4. How can I find AH now? Well, AH is this line represented by this expression. I'm just going to plug in what we found for x. So 2 times 4 minus 1. 2 times 4 is 8, minus 1 is 7. Now to find AC, again, this is an example asking for a total distance. So I want this total distance A to C, and I'm just going to add the pieces. So AH is 7, HC is 21, 7 plus 21 is 28. All right, in this next section here, we want to test if the lines are parallel. To do that, we're going to see if the proportion is true for the side. So what we're going to do is set up our proportion, and I'm going to go with PS over SQ. So this piece over this piece, and I want it to be equal to PT over TR. But we're kind of testing, are they equal? We don't know. We want to see if they are. So I can put a question mark there. PS is 7.5. SQ is 12.5. So I'm just plugging in what we know. PT is 4.5. And TR is 7.5. Now, I don't want to do any cross multiplying here because I'm just simplifying. So I'm going to actually plug in the fractions as they are. So 7.5 divided by 12.5 in my calculator gets me 0.6. I'm going to do the same thing for 4.5 divided by 7.5 in my calculator gets me 0.6. So now we see that they are in fact proportional. And so therefore, yes, ST is parallel to QR because they create proportional pieces. So because they were the same, that proportion was equal, I know that these two lines, TS or ST and QR, must be parallel. All right, let's move into some proofs. So we're going to do a quick review and fill in these common proof reasons based on the descriptions given. So the first description says, when you have two parallel lines cut by a transversal and you can draw the letter F between two angles, we know those two angles are congruent. So that's this picture here where I've got two parallel lines cut by a transversal, and I can draw a letter F. Even if it's upside down and backwards, right? I can still draw the F over these two angles. I know that those angles must be congruent because they're what's called corresponding angles. All right, the next one. Similar, when you have two parallel lines cut by a transversal, and you can draw a letter Z between two angles. So I'm going to draw the letter Z. I know these two angles are congruent. And the way that I know these two is because they are an example of alternate interior angles. All right, the next one says, when you have two intersecting lines that create an X. Remember, the X does not have to be like a super perfect X. It could be a really flat X too. But two intersecting lines, we know that the angles across from each other are congruent. So like this angle here must be congruent to this one here. Let me do that in another color actually. We know that this is true, and this is an example of vertical angles. And the last one, when two triangles share an angle. So one triangle is drawn inside the other. So here we go. Here's my triangle. There's the other one. They both share this angle A. I can say that this angle A is congruent to itself, right? We know that the shared angle is congruent to itself. That is the reflexive property. All right, so let's apply these to the proofs then. In this example, we've got parallel lines. So I'm going to start with my given, as always. WP is parallel to KC because it's the given. And since they're parallel, we want to think about these first two options. Can I draw an F or a Z to create those relationships? And in this picture, I think I could draw the Z across right here, showing a pair of congruent angles. So I know that angle P is congruent to angle C. And if you don't remember, that Z was alternate interior angles. That's my reason. All right, for 3, you could do two things here. There's an example of vertical angles, or you could draw the Z backwards. So I could draw the Z the other direction and see a second pair of alternate interior angles. So angle W is congruent to angle K, again, alternate interior angles. And I can mark those as well. Now, what we've shown in line 2 and line 3 are two pairs of congruent angles. That's enough to prove what we wanted to prove, that triangle PWY is similar to triangle CKY, the reason being angle-angle similarity. All right, and then this last one here, again, we always start with the given. So angle B is congruent to angle S. And looking at this picture, there's another angle pair I know to be congruent. Notice that the two triangles meet at a point where we have intersecting lines. Just like we saw above, where you have that X, you get vertical angles. So I know that this angle is congruent to that one. Now here's where it gets a little bit tricky. When you have vertical angles, you have to label them with 3 letters. So as I label this first one, I'm going to go BWU. I always have to put W in the middle because that's where the angle itself is. So BWU can be the first name. Is congruent to angle. On the other side, I'm going to go SWC. Again, so that W's in the center. SWC tells me I want this side of the angle. Instead of up here, down here, over here, it traces the angle for me. So we're going to say angle SWC. The reason being vertical angles. All right, and so the last statement is what we want to prove, that triangle UBW is similar to triangle CSW. And the way that we can prove it is by angle-angle similarity. Since in lines 1 and 2, we've shown we have two pairs of congruent angles.